What is linked list? Like arrays, a linked list is a linear data structure. Unlike arrays, linked list elements are not stored at a contiguous location. The elements are linked using pointers. They include a series of connected nodes. Here, each node stores the data and the address of the next node. Why linked list? Arrays can be used to store linear data of similar types, but arrays have the following limitations. The size of the arrays is fixed, so we must know the upper limit on the number of elements in advance. Also, generally, the allocated memory is equal to the upper limit irrespective of the usage. Insertion of a new element/deletion of an existing element in an array of elements is expensive. The room has to be created for the new elements, and to create room existing elements have to be shifted, but in linked list if we have the head node then we can traverse to any node through it, and insert new node at the required position. Types of linked lists: simple linked list, doubly linked list, circular linked list. Simple linked list. In this type of linked list, one can move or traverse the linked list in only one direction, where the next pointer of each node points to other nodes, but the next pointer of the last node points to null. It is also called singly linked list, doubly linked list. In this type of linked list, one can move or traverse the linked list in both directions, forward and backward. Circular linked list. In this type of linked list, the last node of the linked list contains the link of the first/head node of the linked list and its next pointer. Representation of singly linked lists. A linked list is represented by a pointer to the first node of the linked list. The first node is called the head of the linked list. If the linked list is empty, then the value of the head points to null. Each node in a list consists of at least two parts. A data item, we can store integers, strings, or any type of data. Pointer or reference, to the next node, connects one node to another, or an address of another node. In C, we can represent a node using structures. Below is an example of a linked list node with integer data. In Java or C#, linked list can be represented as a class and a node as a separate class. The linked list class contains a reference of node class type. Traversal of a linked list. In the previous program, we created a simple linked list with 3 nodes. Let us traverse the created list and print the data of each node. For traversal, let us write a general-purpose function printlist that prints any given list. Time complexity. Search is O(n), because as data is not stored in contiguous memory locations, so we have to traverse one by one. Insertion and deletion are O(1), because we have to just link new nodes for insertion with the previous and next node and dislink exist nodes for deletion from the previous and next nodes without any traversal. Basic operations on linked lists: deletion, insertion, search, display. Advantages of linked lists over arrays. Dynamic array. Ease of insertion/deletion. Insertion at the beginning is a constant time operation and takes O(1) time, as compared to arrays where inserting an element at the beginning takes O(n) time, where n is the number of elements in the array.